Hey everyone, welcome back to the channel. My name is Joseph. I'm a radiology resident at UAB and I do some 3D printing stuff on the side. And today I'm recording weekly update number 4 and I'll be talking about this, which is this modular Arduino concept that I created. It's a short form that I posted last week, but I thought I'd just kind of go through my thought process in a little more detail in this video. So if you're interested in that, hopefully you'll follow along. So let's go ahead and get started. Here's how I made these modular standoffs. While I was prototyping a new idea, I got annoyed at how unorganized things were. So I came up with this modular concept. I started off by making a standardized border piece the size that would work for most components. So this is the border piece that I was mentioning earlier. Go ahead and make this a little smaller. And the way that I made this was I kind of just measured like the mega and then some other pieces and basically based it all off of that. And it took me a little while to figure out what my kind of end shape would be. So if we go back here to the first sketch, essentially just made a size that I thought would work. So I did 120 by 80 is like the inner, I guess, like insert size initially. And then you'll see here, I extruded that out and then added a fillet on the inside. And then I think I just basically created this new offset off of that. And this is when I was playing around with where to put the holes. So I like symmetry in general. So if I put a hole here, I usually like to have the walls, equal distance across. But I also added a chamfer here. So when I added that, the face here looked a little asymmetric. So I actually pushed this off a little bit further than I did this inside wall that I'm making here. And you'll see that here in a second where it's a little bit asymmetric. So that's the outside wall, and I haven't made the holes yet. I just have the cutouts there for it. And you can see here that the hole is a little bit closer to the inside wall than it is the outside wall. But basically I'm just, I know that in the future I'm going to add a chamfer here. And so you'll see that come in, and then it'll essentially be pretty similar as far as how much flat area there is between the center of the hole and this edge and the center hole and the chamfered edge there. So just going to kind of keep stepping through. And this is where I just added the offset for basically so that the head of the bolt can be like flush with everything or recessed, I guess. And then stepping through that's where I cut out all of the holes there. And then let's see. So here is where I'm adding this other offset on the inside. So that's basically to have a lip so that, as you'll see in a little bit, where it'll kind of hold everything, hold the insert back essentially. And then we added that chamfer I was talking about. Now you can see how the face is pretty much the same distance from this edge to the center and from this center to that edge. We can actually measure that real quick. I just use a line here. You can see it's 7 millimeters, and then to this edge, it's like right at 7 millimeters as well. So that's why I did that. I don't know really what the principle in design is as far as like whether you're supposed to use the actual edge or if you're supposed to use the edge of the chamfer. It just makes more sense to me at the flat because that kind of catches my eyes, how much flat is between the edge here and the edge here rather than, including the actual edge of the product or of the wall there in the calculation of like how much space is between pieces. But that's just how I think about it. I don't know if that's really technically true or not as far as like what you're supposed to do. And then here I just added a lot of small chamfers. So I talk about this a lot, but just adding even just 0.4 millimeters of a chamfer really makes the design look a lot better. Just the sharp edges kind of, especially wherever it's printing against, it doesn't always turn out well. So I think adding that really just makes everything look a little bit more refined. And then let's see here. Okay, so this is going to be a part that I want to talk about a little bit, and I'll actually just remake this sketch just to show y'all what I'm doing here. So what I'm doing in this step, and it's really not necessarily needed for these smaller holes, but if you have a bigger recessed hole, it's really important. And I actually learned this from Prusa, which did this, and then there's a video about Maker's Muse that also kind of demonstrated it. But essentially what we're going to try to do is force the printer to bridge over this, because we're printing this face down to give it a good texture. So it's going to be printed like that, like this is the bed plate. So what I'm doing here is I'm essentially about to force this to bridge, and the way that you do that is by making some rectangles. And so I'll just zoom in And then I could do some constraints here. So you're going to make one kind of this direction and one the other direction. And so each of these corners are going to be constrained to the edge of the circle there. And then I'll also make constraints that are tangent with the hole in the middle. So then tangent with that, and then I'm also tangent with this and this. And so now we have these basically two rectangles there. And so what I'm going to do here is the first step is I'm going to extrude all of this all the way across by -0.2. So just one layer height. So depending on what layer height you use, just take off essentially that amount. So -0.2. And so you'll see here, I can actually change just that face color. So we just extruded out that amount. So you can see there's a little wall there. And so from there to there is 0.2 millimeters. And so now I'm going to bring back that same sketch again. And now I'm going to extrude again, just this square part. And now instead of just 0.2, I'm going to do -0.4. So basically 2 layer heights. Click OK. And so now you see we have another layer, and I'll just color that again just to make sure we're all on the same page there. So now you can see we have this, and this is basically 3 different layers. And so what this is doing is, remember, we're printing this way. So we're basically coming up this direction. And then once it hits here, the printer is going to just go straight across. So it's just going to do a little bridge, and this is maybe 3 millimeters or 4 millimeters diameter, so it can bridge this really easily. So you're just telling it go straight across, and it's going to fill this in, and then on the next layer, it's going to go straight across again, because the orange is our next layer. So we're going to have this support, and then we're going to go straight across, and bridge. And then it's going to do this circle, and so it's going to already have these 2 pieces that are kind of supporting it. So the circle should come out pretty easy, and that's just to prevent having the need for supports here. So I just want to walk y'all through that, and I'll actually just export this really quickly and show y'all what that's going to look like here. So just hold on just a second, and we'll pick back up once I'm in the slicer. All right, so now I have it in the slicer, and you can see here that's our feature that we made. So I'm going to go ahead and put this face down. The reason we're doing that is because we want the nice textured finish on the part that we're going to see the most. So I'm going to go ahead and click slice, and you can see here on this one, which is the one that we performed, or that we did that operation on, how it has this kind of box shape, which is what we did. So I just want to step through really quickly what's going on. So this is just kind of the standard infill, and then once we get to our layer that we made, so that's our first layer where we cut out this whole basically this parallel part here, and you can see what I'm talking about. It's going to bridge straight across, which is what we want. And then the next layer, we bridge the opposite direction, and it makes kind of a square, but you can see it has support here. So really all that you're bridging is just these sides. And then the last layer is going to be the circle, and it's just going to carry that circle all the way up. So just wanted to explain that. I think that's really useful when you're doing bores like this, and it's really particularly useful for bigger holes, because sometimes you can get away without this with the smaller holes, but especially for bigger recessed holes, you really want to try and do that. So just wanted to explain it while we were going through this. Okay, so I'm going to go ahead and delete this since I already did it. And then you'll see that I just basically do the same thing. And another thing that I did here is once I made those features that we just talked about, I mirrored it. So you can see here, I'm just mirroring these features across, so I don't have to do that same thing again for every hole. And then I mirror it again, both of these down this way. So that's why it's important to have, the origin there at the center, so you can use mirroring, which is really helpful for speeding things up. Another thing you can consider doing, which is kind of beyond the scope of this video, but you could make a solid part. So you could basically just fill this in and then cut that out. So you could basically have like a negative to cut these features out with that would also be, they could be patterned and basically save you some time on that end. And so now at the end, I pretty much had everything done, but I thought the front kind of looked a little boring. So I added this last little feature here. And so what I did was I used that original curved line that I created way back here. I projected that into this, and then I had an offset 1 millimeter in both directions. And I basically just drew these squares around the part to have basically these rectangles that are centered. If you consider that the midline, I use this as the center line. And then the reason I made these rectangles was just to square off the edges there at the edge of the circle or the radius. So then I had a nice rectangle to extrude. So then you can see here I extruded that with this. So now I have a small rectangle, and then I made them into slots by just filleting the edges there. You can see I had those filleted off. So that is how I made kind of the outside part. And again, these are reversible, which I'll talk about in the shortly, but you can see how you can set these inserts in this way and they'll kind of protrude up a little bit, or you can make them flush the other way. So we'll go back to the video. These recessed holes in the corners to use these joint pieces with, so you can organize them however you want. I made joints for all 4 possible configurations. The insert pieces so the joints, I don't want to go into a lot of detail with that, but essentially all that I did was I created an assembly similar to this one. It's not this exact assembly, but put these side by side, and then I just projected the holes out, and I projected basically the boundaries here and gave it a small offset, and then essentially just extruded out the holes there. And you can see here, for example, this is one of the assembly joints. So the reason that they're recessed like this is so that you can put these on either side. So if you put it on the top, you'll have the bigger recessed hole, so that should catch it. And if you put it on the bottom, which is also an option, this smaller hole, this smaller kind of peg part will be the part that's interacting with the hole on that side. Standoffs that fit the holes for different prototyping boards like these Elegoo Mega and Uno boards. My initial insert pieces look like this, but I ended up liking the slim border better to make things look more consistent. The reason some of these arms are at weird angles is to avoid the solder on the back of the boards. I also made a blanket. For the inserts, I think I did the Uno first, and it was fairly straightforward. So if you remember back to that first sketch I did, the inside part was 120 by 80, and you can see here I just made these 0.4 millimeters shorter in both direction, or in width and height. And so that gives you 0.2 millimeters on each side, which is a pretty good amount of clearance that I typically use. And then after that, I basically just picked kind of a standardized, basically width of the kind of insert of 4 millimeters, which I just kind of thought that looked okay. I didn't do anything special with math on that. And then this was just me finding the holes location for the Uno in particular. And I couldn't find a great reference for those. I used a different kind of sources online, and I ended up measuring a lot of it just to kind of confirm, because these are a little offset. You can kind of tell here, but if you're just looking at it, it's kind of hard to see that. And then I adjusted where these were in space so that the Uno looked pretty much centered. It's not perfect, but it's pretty close. And so I'll just step through this really quick. It's pretty straightforward once you get the hole locations, which is kind of the hardest part. So this is kind of the first extrusion, and then I added the fillets here. And if you'll remember, I talked about this in a previous video, but to get these walls to be the same width with the fillets, you have to basically add the width of the wall. So we said it was 4 millimeters wide, so this is a 1 millimeter fillet. You can see that there. And then this outside one is 4 millimeters, and that makes the wall in the curve the same width as the straight part of the wall. And then so I made that's where I just added the fillets kind of in the corners and all the joints there to make things look a little smoother. And then the next step was I just added that fillet on the outside, and then that's going to fit kind of flush with the border piece that we made previously. And then this was just to basically make a offset here so that I could extrude everything up, and I didn't want to extrude over these holes, so just basically projected this whole surface, and that gave me a way to project this up to make it flush. And I'll open up one of the other files here in a second. And so I extruded that up. You can see there, basically used that part that I projected and then made that come up a little bit there. And then I just added the 0.4 millimeter chamfer basically all the way around everything, and that really helps with the holes because that kind of basically leads the bolt in there. And these are basically just friction bolt. They join from friction. Basically, you thread it into the plastic, and I think that works good enough. I mean, these aren't under a lot of pressure or a lot of force, generally speaking. And then at the end here, I added just a little bit of, or changed the size of the part there so that it fits a little bit better. All right. And so that's all there is to that. And then if we come over to here, let's see, this is the part that we were working on. You can see that that fits flush. And then we have, I'll do a inspection here, section analysis. You can see how that fits flush up under. Oh, that's actually for the insert. So let's do another analysis here. And so you can see here that we have a nice 0.2 millimeter of space all the way through. So everything fits with a little bit of clearance there. And then everything is pretty symmetric and, the same on both sides. So that is how I did that section. And then let's just keep going here. So I made this blank one as well. So that's going to be this insert here. And if you'll go to the school community, which is where these files are available for free, I have this template one available too. So what I would do with this template, if I was trying to make another, basically offset. So right now it has this fillet at the end. So I would actually go back one to here, and then I would create my my standoffs here. So let's just pretend that we have another part. So I would probably use slot. That's kind of the easiest thing in my opinion. So you can just basically have it wherever you want here. And then I think this will be 4 to keep everything consistent. And then the hole would be here. And then you would basically just need to find, how far off you need to go and then position it a certain way. And then if it's symmetric, you can use just this rectangle here and basically figure out the whole position. Something like that. And then you could just, instead of using that width there, this is probably the better way. And then whatever size screw hole you want. I think I ended up using like around 2 point something. Let's see. So my final hole diameter here was 2.6. So it's probably a 3 millimeter thick bolt. So 2.6 seemed to work okay. It's a little tight, but it's close enough. And so you can imagine, if you had basically just, this was where your holes were, so then you can just, you could basically just use this and mirror it around. So I'm just going to do that real quick. So we have that there. And so now that I have that, I can just copy it a couple times. So we're going to do create mirror, and then we're going to change this to features. And then our object is going to be that extrusion that we just made. And then our mirror plane is going to be the origin. So now we have both sides, and then we can just mirror it one more time. Mirror, again, it's on features. Objects are going to be this and this, and our mirror plane is going to be here. And so this is just saying if those holes were in the same position. And again, you might have to change the angle a little bit depending on how you want everything to look. And then I would also add 1 millimeter fillets here if you just want everything to be consistent. You could actually have done this before we mirrored everything, but I'll just go with it now that we're here. Okay, and then the last step would be to add this fillet, which should apply to everything. And so now you've made your own template. So again, you can just take this rim template. I would just go before, if you have Fusion, just go before that fillet and then design whatever you want. And then remember to add 1 millimeter fillets on the standoff kind of pieces here to make them the same as this, which is 1 millimeter, as you can see down here. So that is how you make your own custom insert there. So I'm just gonna delete that and not save it. And then this one again is just for adhesive things, so which I'll show that in a second. For attaching these breadboards using the adhesive on the back. The inserts are also reversible. Everything can sit flush like this. So this is what I was talking about. You can sit it flush, which is good if you're kind of moving it around on the surface, but obviously you can't pick it up and move it anywhere with it this way. Or you can flip the board over and sit the inserts inside of the border piece like this. And so that way you can carry them around if you need to. The joint pieces can also be added to the top or bottom of the border depending on your preference. So this is where I was talking about the bigger part kind of inserts more on the front, and then on the back it's a little bit offset, but it still works okay. Another neat feature is being able to stack them vertically using these supports to free up some extra desk space. And so this is just another concept I came up with. I took the single joint piece and basically extruded that out, and I had added these hexagon rods. And the reason I use hexagons, which I've mentioned in the past, is you can print this sideways really easily because the printer, does straight lines really good, and these overhangs are really easy for it to print as well. So these usually come out pretty good. I added a small amount of tolerance, so you might have to use a little bit of force to get them in, but they're it's pretty solid once you get everything all the way in there. And then basically you can just stack them up, which is kind of a nice feature to save some space if you're basically have your design kind of ready to go and you just want to have it kind of to itself. It's not like super sturdy, but it's pretty sturdy. I mean, it's good enough for most use cases. I made the supports print as 2 halves with this inner hexagon rod to join them together so that I could print both ends pointing up, which eliminates the need for support. So this is a big kind of realization I had. There's a lot of stuff you can that is symmetric like this. You can eliminate the need for supports by just splitting it, and this is a pretty effective way to split it. But I do want to mention that you need to print the A and B part for each section. They're not the same thing. They're actually they're not they're not the same. So they're like mirror images, but they're not. You can't just print all the part A. You have to print part A and part B, and then the hexagon rod. As an extra bonus, you can even use the border piece to mount boards onto the side of a prototype like this. And so I think this is also a nice kind of feature of this system is you can use it to mount things, and it's pretty straightforward. You just need to put the holes, in the right spot, which let's see exactly where the holes need to be. I think it's 120. Actually, it's not going to be exactly 120. Let's see. I'll go ahead and find that real quick for anybody. Yes, it's a little bit of a I should have thought about that beforehand, but it's not like a very intuitive number. So the easiest way to do that, in my opinion, would be to just put this into the part wherever it is and then just project this off. So basically you would project these holes and you could extrude your holes into the part that way. So that's probably the easiest way. It's not like a perfect number. As you can see here, it's like 124.1 and then 184 or 84.1. So that could have been thought out a little bit better. But I think when I was just trying to make everything symmetric with the holes and with these different like basically overhangs, things like that, I kind of lost track of what these distances were, which is really not a huge deal. It would just be a little bit more, I guess, streamlined if there was a specific, width that kind of rounds off to a whole number. So files are available for free in my group. Thanks for watching. All right, so that's about it for this one. Hopefully you enjoyed it and maybe learned something about making something like this. And if you want the files, they're available for free in my school community. The link is down below. Thanks for watching.